This is Earth. This is our home. It is both solid and steadfast, but also fragile and vulnerable. Experts tell us that the Earth's climate is rapidly changing, presenting a real and major threat to our future. But the causes and effects can be hard to comprehend. Introducing Climate Station. See for yourself how much the climate has changed over the last century. Discover what is causing these changes and the effects they're having on the natural world. Find out what the world could be like in the future if we tackle climate change quickly, and what could happen if we don't. We cannot solve a problem without first understanding it. So, let's begin our journey of exploration. Welcome to Climate Station. You are about to see how the weather affects our planet over a complete year. It's the 1st of March, 2019, the beginning of a meteorological spring in the Northern Hemisphere. Let's start the playback. Every 2 seconds marks a day, another complete rotation of the Earth. At this time of year, tropical cyclones form in the southwest Indian Ocean. This one is called Cyclone Idai. It will turn out to be the second deadliest ever recorded in the southern hemisphere. Over 1,000 people across East Africa will lose their lives. This year, the temperature distribution of the Indian Ocean is uneven. The eastern side is unusually cool, and the western side is unusually warm. This warmer water contributes to Cyclone Idai's record strength, and Africa will have increased rainfall throughout the year. On the other side of the ocean, where the water is cooler than normal, there will be drought. Let's jump to May and look at North America. At this time of year, a flow of warm, humid air heading north clashes with another flow of cool, dry air heading south. Where they meet, supercell storms begin to form. These intense thunderstorms can generate narrow, violently rotating columns of air known as tornadoes, which can achieve the highest measured wind speeds on Earth. Sometimes over 400 kilometers per hour. Further north, you can just see the smoke from huge wildfires in Alberta, Canada. Dry, windy conditions are helping them to spread to a much larger area than normal. As the year advances, the point where the sun is directly overhead at midday has been shifting northwards due to the tilt of the planet. It has reached its northernmost position at the Tropic of Cancer. On that imaginary line lies India, and the direct sunlight is contributing to an intense heat wave there. But it's not just near the equator that's affected by high temperatures. Near the Arctic, it is much warmer than usual, and in Siberia, an area the size of Belgium is on fire. Europe is now experiencing a heat wave as well, and hundreds of people will succumb to the record high temperatures in the next few days. The European heat wave in 2022 will be the deadliest weather event worldwide that year. Meanwhile, back in India, monsoon rains arrive. They form every year when a difference in heating over land and ocean causes a change in the wind direction. They're later than usual, but the most intense in 25 years, fueled by the same warm water that's linked to the increased rainfall in Africa. Over in South America, fires in the Amazon rainforest, which have been burning for much of the year, now reach their peak. They started intentionally to clear land for agriculture, but high temperatures have dried out the vegetation, allowing the fires to burn more intensely and spread more quickly. They appear in much greater numbers this year than normal. As summer progresses in the Northern Hemisphere, the Atlantic Ocean has been warming up. Conditions are now perfect for the formation of tropical cyclones, such as this one, Hurricane Dorian. It's just made landfall in the Bahamas and is about to become the region's worst natural disaster on record. The damage is catastrophic. At least 70,000 people are left homeless, 84 people lose their lives, and over 200 are missing. Dorian begins to fade and tracks up the coast of the eastern United States. Air currents will transfer that heat and moisture all the way to the Arctic Circle. The Arctic is particularly affected by rising temperatures. On this day, the amount of Arctic sea ice is the second lowest since satellite records began in the 1970s. Back in the Atlantic Ocean, not all hurricanes head towards North America. This one, Hurricane Lorenzo, is traveling towards Europe, and it's the most easterly tracking Category 5 hurricane on record. By the time it reaches the cooler waters around the British Isles, much of its strength is gone. But as the climate changes, will that always be the case? On the other side of the planet, another tropical cyclone called Typhoon Hagibis is also traveling further than usual. As it hits Japan in time for the Rugby World Cup, it is one of the strongest typhoons on record and will become one of the costliest. Further south, Australia has been experiencing months of drought. It is on the cooler eastern side of the Indian Ocean, where rainfall is reduced. Record high air temperatures have made things even worse. Bushfires are already widespread throughout Australia and now in December reach their peak. The fires are having a major impact on the area's ecology. Billions of animals have lost their lives, and many areas will take years to recover. Today, on the other side of the world, a Boeing 747 makes a record-breaking transatlantic flight, New York to London, in just 4 hours, 56 minutes. This incredible feat has been helped by a strong jet stream, acting as a powerful tailwind. This high-level current of air is far stronger than usual and is also sending a conveyor belt of storms towards Europe. They hit, one after the other, making it the wettest February on record in the British Isles. That brings us to the end of our eventful year of weather for planet Earth. Another year of extremes affected by rising temperatures. 2019 was the second warmest year on record, and 2020 will go on to be even warmer. In the middle of the last century, few people were interested in climate change. Levels of greenhouse gases in the atmosphere were unknown. Temperatures were being recorded, but no one was assembling them to make an accurate global picture. At this time, a young researcher called Charles Keeling was working out a way to measure the level of carbon dioxide in the atmosphere. He found concrete proof that as the level went up and down with the seasons, it was also steadily rising. A few scientists had already said this was likely. Burning fossil fuels rapidly releases millions of years of stored carbon back into the atmosphere. And it was concerning. As a greenhouse gas, carbon dioxide acts like a blanket that traps the heat, so it causes the whole planet to warm up. Fast forward to the present day. We now have a complete picture of how much carbon dioxide has risen in the atmosphere. The level is still rising, and in 2021, it had increased by an astonishing 50% since humans embarked on the Industrial Revolution. But it's the rate of change which is most concerning. Over the last 120 years, other major factors that could influence global temperature have had negligible impact. Factors such as the amount of energy from the sun or the amount of dust from volcanic eruptions that would block the sun's energy from getting through. So, we know that rising levels of greenhouse gases have been the main influence on the climate over the last 120 years. But how much have they affected the temperature of the planet? Years of records from all over the world have now been brought together to give us a picture of how the overall global temperature has changed over time. As expected, it's risen. The temperature is now far higher than it was a century ago, but it's the rapid rate of warming that has been most concerning. The true effect has been masked, though, because 90% of the extra heat has been absorbed by the oceans. Since 1955, we've been able to monitor this too. Over many years, the heat will gradually be released again back into the atmosphere. Even if levels of greenhouse gases can be reduced, unfortunately, this heat will keep global temperatures higher than they otherwise would have been. So far, we've looked at the overall effects, but let's now see how temperatures have changed in various locations across the planet. Let's start in 1901 and run through the years to the present day. The pins show the difference in temperature relative to the middle of the 20th century. Blue pins are cooler. Red pins are warmer. The longer the pins, the greater the difference. Watch how the cooler blue areas gradually disappear, and then the warmer red pins take over as the planet warms up. You can see how the warming has accelerated, particularly in recent years, and some areas have warmed more than others, especially the Arctic. This Arctic warming has had major consequences. Since 1979, satellites have been able to monitor sea ice, and the amount in the Arctic has reduced dramatically. Ice is good at reflecting heat back into space, so the reduction has caused the ice-free ocean to absorb even more heat than it previously would have, causing yet more warming. If we look at the temperature records for Svalbard within the Arctic Circle, the rise has been particularly noticeable in recent years. This has led to the glaciers there dramatically reducing in volume. This shows how the glaciers were in 1936, and this is what they're like now. The red areas highlight how much ice has melted away. But it's not just at this location. In only the last 40 years, the average thickness of the world's glaciers has reduced by 24 meters, the height of an 8-story building. Ice sheets are reducing too. We've only been accurately monitoring these since the 1990s, but in that time, Greenland alone has lost nearly 5,000 gigatons of ice. When melted, that's almost double the volume of Lake Victoria in Africa. All the meltwater from land-based ice sheets and glaciers flows into the oceans, causing the sea level to rise. This is made worse by the ocean waters expanding in size as they warm. This graph shows the global rise in sea level over the last 120 years. Half the increase has happened since the early 90s. As with temperatures, some areas are affected much more than others. Some low-lying areas are already under threat. It is difficult to prove that specific weather events are caused by climate change. But we do know we have seen more extremes as the planet warms. There's been an increase in heat waves, with many temperature records being broken. Changes in rainfall patterns have led to more frequent and severe weather events at either end of the scale, from droughts to floods. The past 9 years were the warmest on record globally. When Keeling first made his discovery, we had little evidence of climate change, but as each year goes by, we gather more data showing how much the climate is changing. The Earth's atmosphere contains 78% nitrogen and 21% oxygen. The other 1% is made up of greenhouse gases, such as water vapor, carbon dioxide, methane, and nitrous oxide. That tiny 1% is crucial for regulating our climate. Without greenhouse gases, the Earth would be far too cold to live on. They act like a blanket, keeping the planet warm. As with the glass in a greenhouse, they help to trap the heat from the sun that would otherwise radiate back into space. So why do we want to get rid of them? Because human activity is rapidly increasing the levels of greenhouse gases in the atmosphere. This is heating the planet beyond the level that many plants and animals are accustomed to, and faster than they can adapt. This shows all the main contributions humans make to our climate, representing both warming and cooling effects. The main greenhouse gases are highlighted, with carbon dioxide having the largest warming impact. Since parts of the world became industrialized, the level of carbon dioxide in the atmosphere has increased by a staggering 50%, and the increase is accelerating. By using methods such as analyzing samples from the bottom of the ocean, we now know the level hasn't been this high for at least 2 million years. It would be even higher if some of the extra carbon dioxide hadn't been absorbed by the land surface and oceans. Methane is the second highest contributor. There's around 200 times less of it in the atmosphere, but it's much more effective at trapping heat than carbon dioxide. Since pre-industrial times, its level has more than doubled. In fact, it's risen an astonishing 10% in just the last decade. By far, the most abundant greenhouse gas is actually water vapor. It's created by evaporation and removed by rain. The amount of water vapor in the atmosphere varies with atmospheric temperature. For every 1 degree Celsius of warming, the atmosphere can hold 7% more moisture. But remember that water vapor is a greenhouse gas, so that extra 7% will cause even more warming. It's a feedback loop, and this behavior amplifies the heating effect of other greenhouse gases too. When they warm the atmosphere, more water vapor can be stored, leading to even more warming. Most water vapor is invisible, but a minority forms the clouds that we see, which are particularly good at trapping heat, especially at higher altitudes. Some do reflect energy from the sun back into space, though. This offsets part of the warming. So, greenhouse gases from human activity are causing the planet to warm. But what would happen if we completely stopped emitting them? The challenge is that even if we did completely stop emitting them, the amount already emitted won't instantly disappear. So how quickly would the levels go back to how they were before we began our greenhouse gas emissions? The methane would dissipate in around 10 years, but it could take hundreds of years for the level of carbon dioxide in the atmosphere to do the same, and even longer for the oceans. If we want to stop the planet warming, ideally, we not only need to reduce our emissions, but find ways of mopping up the excess greenhouse gases that are already there. What might the rest of the century be like for our planet? As the Earth warms, the impacts of climate change become greater. Currently, the global average temperature is around 1.2 degrees Celsius higher than it was before the Industrial Revolution, and already we're beginning to see some of the effects. In 2015, most countries in the world signed the Paris Agreement, with the aim to keep the temperature below 2 degrees Celsius of warming and focus on limiting it to 1.5 degrees Celsius. Even if the temperature stays below this level, it won't solve all the issues. The 1.5 degree target has just been chosen to protect us, not as a guarantee. So, would keeping this agreement have any benefits? Alternatively, what might the consequences be if we don't? The projection section allows us to explore the possibilities, using information taken from the best climate models we have today. The results all depend on how much greenhouse gas we release into the atmosphere. So in this section, we can choose from a range of different emission scenarios to find out what would happen. For each potential future, we can observe the change in temperature over time and the impact it would have on a variety of different factors. In many ways, it's just like the observation section, with the global trend graphs and selectable regional temperature pins. This time, however, the graphs are more suited to showing general long-term trends rather than specific years. The model simulations give us access to far more data than was observable in reality, particularly before satellites became available. So, this section contains additional information that helps us to see more of the impact both on us and the natural world. We can pull up maps showing detailed climate information and how each part of the world would be affected. These are plotted for each level of global warming, the 1.5 and 2 degrees Celsius targets, plus the nightmare scenario of reaching 4 degrees Celsius. We can look at two different types of data simultaneously to make side-by-side comparisons. We can see that some areas would become wetter, while others would face severe drought. For each emission scenario, we can also monitor a range of specific risks for the planet's climate and how quickly they would increase as we move through time. We can see that even now, warm water corals are under threat. But thankfully, at least the risk of climate tipping points, the points of no return for the planet, only increase at much higher warming levels. The calculations assume that society hasn't taken any actions to adapt to the changing climate, making the consequences as severe as possible. This is accurate for less developed parts of the world and elsewhere if change happens quickly. By reducing our greenhouse gas emissions, we can both slow down the warming of our planet and reduce the very worst long-term impacts, providing us and the natural world with more time to adapt. Climate Station has allowed us to gain a new appreciation of our planet's climate and how it's changing. The story continues to evolve. In 2023, the global temperature suddenly surged. It was warmer than any previous year ever recorded, only to be surpassed by 2024, which exceeded 1.5 degrees Celsius above pre-industrial levels for the year. Remember that most of the heat is stored in the ocean, hiding the true scale of the problem. On our current course, by the end of the century, the planet will have warmed by nearly 3 degrees since pre-industrial times. Heat waves, droughts, and heavy precipitation will become more frequent and intense. Tropical cyclones are more likely to generate devastation on the scale of Hurricane Dorian, as shown here. The consequences will affect everyone. But this doesn't have to be our future. We know what's causing the problem. Burning fossil fuels has released millions of years of stored carbon back into the atmosphere, causing it to heat up. Meanwhile, we've destroyed natural features such as peatlands and forests that would have helped to recapture this carbon. The Paris Agreement set out a goal of net zero emissions by 2050. The amount of carbon we release should be balanced by the amount we capture again. This would reduce warming by the end of the century to 1.5 degrees, far less damaging than the 3 degrees where we are currently heading. We've already come a long way and rapidly adopted green energy technologies. About 15 years ago, climate research indicated we were heading to nearer 4 to 5 degrees of warming by 2100. So, there is still hope. But hope is delivered through action, and we need to act now. We need to reduce the amount of fossil fuels we burn as much as possible, switching to renewable energy. We need to restore and expand natural features such as peatlands, forests, and seagrass to capture the carbon that we do emit. Everyone needs to play their part. This is true for us as individuals and as communities. We can encourage industries and nations to play their part too, by the choice of organizations that we support. There are 8 billion of us on the planet. It's all down to the choices we make. How we travel, how we heat our homes, and what we consume. The challenge is to ensure that as many people as possible understand the situation we're in. This is the first step towards positive change. Everyone's contribution to limit further warming will make a difference. Every fraction of a degree matters. Our introduction to Climate Station is now complete. You're now welcome to continue your journey and discover your very own climate story.